Fittune is a competitive fitness tracker and run planner for smartphones. It is a mobile application designed for both Android and iOS and is written in Flutter and Dart. Its backend consists of a Ubuntu server with a RESTful API written in Node.js, a WebSocket server written in Node.js, open source rooting machine, as well as Firebase authentication and Firebase real-time database. The application allows users to plan their runs and walks by designing a route for them in their local area, which they can then follow along a map in real time. It provides voice directions and allows them to race against other users live online. It also provides users with insights into their performance in real time. Let's have a look at some of its functionality. Upon opening the app for the first time, users can sign up using their Facebook or Google account seen on the custom designed login screen. They are then prompted to input their age, height and weight, which is used to calculate performance data, such as calories burned or stride length. If the user enters invalid input, they will be informed to make amendments. The user is then prompted to grant the application access to movement and location permissions, which are required for the application to work. Users can choose to go for a run or walk in both online and solo offline mode. By selecting the Generate Route option from the Design Route screen, users can enter their desired exercise distance and be presented with a choice of suitable routes in their area. A HTTP request is sent to the RESTful API, which communicates directly with the open source routing machine, OSRM, running on the same Ubuntu server. The API plots 5 geolocations and attempts to build a route between them that matches the desired route length. It then adjusts these to improve accuracy with weights. It attempts to build at least 4 routes in this way and return them to the user. Users also have the option to draw their own route on the map. Each time they click on a point on the map, a HTTP request is sent to the API, which returns the shortest route to that point in geo-coordinates, again by communicating with the OSRM. These are then plotted on the map just like the generated route coordinates are. Users can undo points they've added and also save their generated or drawn routes to use in the future. Signing out is a simple process accessed from the main menu. This makes it easy to sign in as a different user with another account, such as Facebook. Users have the option to delete their account and data from the main menu. The user receives a warning and is prompted to enter the code on screen to confirm the deletion. The account will only be deleted if the user enters the correct code. This involves communicating with Firebase to ensure that the user's access token is now invalid. As can be seen, when logging in with the same account after, the user is asked to register a new account again. Users can undertake solo offline exercise by selecting from the main screen and designing a route or picking a saved route, which is pulled from the Firebase database. A countdown is then displayed to the user, allowing them to prepare to begin the exercising. While exercising, users can view their current position along the route using the real-time map. This makes use of the device's GPS functionality to update the user's position. In the control bar at the base of the map, users can view how long they've been exercising for and pause or continue the timer if they need a break. They also have an option to finish the exercise, which displays a summary page of their performance and an option to save it. When completed and saved, their exercise is backed up to the Firebase database where it can be used for exercise history and performance statistics. The user can monitor their live exercise performance using the live statistics below the control bar. This shows how many calories they have burnt, their average speed, as well as distance covered. These have all been calculated using a combination of the user's health data provided at sign-up, GPS movement, and the device's accelerometer. Online mode enables users to race against one another in real time. The following clip shows how this is done from the perspective of 2 runners. The application connects to the backend server and a WebSocket connection is established. This allows for real-time communication between the server and users' devices. The server acts as a middleman between users and places the newly connected user in a user pool based on their exercise distance, where they must queue for another user with a similar exercise distance to race against. Once another user joins, they are matched together and a countdown is displayed to both. During the exercise, the server communicates updates between both devices, which allows the application to show the opponent moving along a user's map, the user's position in a race, as well as send and communicate chat messages. The connection to the WebSocket server is secured using an access token. Any connections or messages that are not signed with a valid access token are rejected by the server. In online mode, users can also send one another chats during the race. The user can scroll through a selection of encouraging and funny messages to send to their opponent. These are pre-written to save the users having to type while running. Again, these chats are sent over the WebSocket connection. Users can also review their past exercise history from the Statistics tab on the home screen. Here they can see a list of past exercises which are stored in the Firebase database and pull down asynchronously. By clicking a past exercise, users can view a replay of their run. This simulates their pace and movement throughout the race using the data recorded during it. This can be paused or continued using the control bar. Users can also see a scrollable list of statistics from the exercise, including their average speed, distance covered, and total calories burned, for example. Exercise history can be deleted by swiping it away. In conclusion, Fittune is a fully featured competitive fitness tracker and run planner for smartphones. It runs on both Android and iOS, has a fully secured RESTful API and WebSocket server backend, which runs on Ubuntu server. It uses its own self-hosted instance of the open source routing machine using OpenStreetMap data. Thank you very much for watching.